All right, so lesson 6.1 is titled Matrix Notation and Algebra. So we're going to have to do some algebra in here with it. I wouldn't consider it algebra, it's more of adding and multiplying, so it's not a huge deal. This one, it starts out in example 1 asking you to look at these 4 sets that they're looking at, these 4 matrices, and they want me to find the dimensions of each of them, but they also want me to do a couple of other things. So let's look at first just the dimensions of them. So the first thing you have to know when you look at the dimensions of a matrix, you're looking at the amount of rows compared to the amount of columns. So when I look at a matrix, maybe write this up here. These going this direction, those are my rows. And these going this direction, those are my columns. Okay, let's see if you can actually see that. There we go. Okay, so these are my rows, these are my columns. So when I name the dimensions of a matrix, I go rows and then columns. Okay, so it should be rows by columns. Okay, so for A is a 2 by 3 because there are 2 rows, 3 columns. Okay, then they want me to find the 2,1 entry of A. So let's talk about what that means. The 2,1 entry tells you which row you're supposed to look at and which column you're supposed to look at. So the row that I'm looking at is row 2. So row 2 is right there. And then the first entry in that row is 4. So let's write it out like this. The 2,1 entry of A is 4 in this case. Okay. B is a 2 by 2 because it's 2 rows, 2 columns. And then they want me to find the 1, 2 entry of B. So the 1, 2 entry of B. So again, I'm looking at my first row, second entry. So that should be 0 in this case. C is, how many rows does it have? It has 3 rows, only 1 column. So a lot of people mix this one up, so make sure you look at your rows. So 3 rows, 1 column, and then they want me to find the 3,1 entry of C. So the third row, first entry is 5. D, the last one, is 1 row and 4 columns. And they want me to find the 1, 1 entry, which is very simple. It's just that first one, which is negative 0.2 in this case. Okay. The second example, they want me to decide whether these are vectors, and if so, give their dimensions. And then they also want me to find the second coordinate of each one that is a vector. So let's talk about what vectors are. There's something called a row vector and a column vector. A row vector is a single row with so many columns, doesn't matter. A column vector is something with 1 column with several rows. This one right here is kind of an interesting one. This one only has 1 row and it only has 1 column, so it is actually both a row vector and a column vector. This one is neither. This doesn't have a single row or a single column. It has more than 1, so that's not a vector. All right, so let's talk about each of them individually. So W is we said this is a row vector because it has 1 row. And it has a dimension. It'd be nice if I could spell dimension right. Dimension of, let's see, it has a dimension of 1, 2, 3, 4, 5. So that just tells you how many columns are there. I guess you could think about it that way. Or if you're talking about a column vector, you're asking how many rows or how far does it go out or down. So this one goes out 5. And then they also wanted to know what the second coordinate is. So the second coordinate is 3 in this case. Okay, x is a column vector. It has dimension 3, because there's 3 of them there. It goes out 3. And then the second coordinate in this case is 1. Excuse my messy handwriting here. You get the idea. Y is actually not a vector. So we talked about that. This one is not a vector at all. So in that case, you don't have to give a dimension or the second coordinate because it's not one. Z is both a row and column vector. It has a dimension of just 1 because it doesn't go out anymore or down anymore. And there is no second coordinate on this one because there's only that one value there. Okay, so that just gives you some basics about matrices. Hopefully none of that is too confusing. Let's get into where I was talking about some algebra happening. So in this case, it's really more like arithmetic, right? So this one is saying, I just want to know what A plus B is. Well, if your two matrices that you are adding together have the same dimensions, you can add them. So I'm just going to go through and add each position that kind of coordinates with one another. So if I'm going to add these two, A plus B would equal, it's going to end up the same dimensions. So this one is a 3 by 2. This one is a 3 by 2. So I'll end up with a 3 by 2. And I'm just going to add each position. So a 3 and a 2 put together is 5. A 2 and a 1 put together is 3. 1 and 0 is 1. 2 and a negative 1 right here would be 1. And then a 0 and a negative 1, negative 1. 2 and negative 3, negative 1. So that's me just adding those together. Part B is saying, I want to know what 2 times A is. Again, that's very simple. You're just going to take A, every value in A, and multiply it by 2. So 2A would equal, it's still going to be a 3 by 2. This time everything's going to be doubled. So 6, 2, 0, 4, negative 2, 4. Okay, and then part C here, they want to know, well, what is negative 1 times B? Again, same dimensions. I'm just going to take everything times negative 1. So negative 2, 0, 1, negative 1, negative 2, 3. Okay, example 4. This one is saying they want me to find U times X. So there's kind of a rule we have to know about. So U in this case, U is a 1 by 3, right? So U is a 1 by 3. X is a 3 by 1. If I'm going to multiply these two times each other, these middle two have to match. So if I have a 1 by 2 times a 3 by 1, I can't do that. It's not possible. So in this case, I can do this. And then not only that, it also tells you what your answer is going to look like. My answer, if you look at the outsides, will be a 1 by 1. So these kind of cancel each other out, I guess, and you get a 1 by 1. So let me show you what that looks like. So UX, when you multiply them, you're going to go across this direction from your first one. So I'm going to take my first matrix and go across it, and I'm going to go down my second one. So I'm going to do 1 times my 4. on the top there. And then I'm going to add or subtract. In this case, I'm going to subtract because this is a minus sign right here. And then 1 times my second one, 2. And then this one I'm going to say plus, because it's a positive 3, times negative 1. And then I am literally going to add or multiply or subtract whatever it's telling me to do here. So in this case, that would give me a 4 minus a 2 minus a 3. 4 minus 2 is 2. 2 minus 3 is negative 1. So my resulting matrix is just negative 1. It is a row and column vector of negative 1. Okay. Example 5. So same idea. Let's do the same idea here. This one is multiplying A times B. So let's check it and see what I've got here. A is a 2 by 3. B is a 3 by 2. So these do match up. That's good, which means I'm going to end up with a 2 by 2 for my answer. Okay, so let's look at what that actually looks like here. So I know I'm going to end up with a 2 rows by 2 columns. So my 2 rows, I'm going to go across this one and down this one. I think I always get these mixed up because I'm used to looking down first, because when we're naming them, like when I'm naming this a 2 by 3, I look at this way first and then that way. When I'm multiplying, we have to go across this way and down this way. So that gets kind of confusing. All right, so I'm going to do 2 times my 1. And then plus, I've got a 3 times a negative 1. And then minus, I've got a 1 times a 1. So that's my first, this right here is my first entry in this matrix. Okay, my second one, so let's go down this direction. So I'm going to go this way, but I'm going to stick with this one right here. So I'm going to stick with my 1, negative 1, and 1, but this one I'm going to go down this direction. So I've got negative 1 times 1 plus 0 times negative 1 plus 2 times 1. So that's the next one down, the next entry down. I go down in this row, but I stick with this column. When I go over to do my second 2 entries, so there's 1, 2, I'm going to have 2 more because I've got a 2 by 2, right? These 2 entries are going to be involving this row, this column, but I'm going to do these rows again. So my top one up here is going to be this row, so 2 times this column over here, negative 1, plus 3 times 0, so 3, 0, minus 1 times 2. And then the bottom one is going to be my second row, negative 1, but again times this column. Okay, so then I'm going to simplify that. So all of this simplifies down. This would really be 2 minus 3 minus 1 on top. This one would be a negative 1 plus a 0 plus a 2. This one over here would be a negative 2 plus a 0 minus a 2. This one would be a 1 plus a 0 plus a 4. So then let's actually simplify that all the way down now. So 2 minus 3 would be negative 1 minus another 1 would give me negative 2. This one, negative 1 plus a 2 would be 1. This would give me a negative 4, and this would give me a 5. So there's my 2 by 2 matrix at the end. Okay, last one, let's find BC. So B is a 3 by 2. C is a 2 by 2. Again, these match up, so we're good there. So I'm going to end up with a 3 by 2 for my answer. So a 3 by 2. So I'm not going to put that second one because I don't know how far it's going to take me over. So I'm just going to stop there. All right, so now, again, I have to think about these from my first one, I'm going to erase these arrows because now I'm going to go backwards here. So my first matrix that I'm talking about here, there we go, get back in focus. So B, I'm going to go across, and C, I'm going to go down. So this would give me 1 times 1 minus 1 times negative 3. Okay, and then I'm going to go ahead and do the one below it next. So I'm going to go down across on this one and stay with this column. So negative 1 times 1 plus 0 times negative 3. Next one down, I've got 1 and 2. So I've got 1 times 1 plus 2 times negative 3. And if you notice, there's kind of this pattern here, right? These are showing up every time because that's that column. Then I go to my next one. So now I'm going to go back up to my first one here, but I'm going to use this column instead. So 1 times negative 1 minus 1 times 2. And then I've got a negative 1 times negative 1 plus a 0 times 2. Last one, I've got a 1 times negative, what am I doing here? Negative 1. 1 times negative 1 and 2 times 2. Okay, so now I'm going to simplify these. So that's going to give me, I'm going to go ahead and simplify it completely this time. So 1, this would be a positive 3, so 1 plus 3 is 4. This one, this would give me negative 1 plus nothing, so that's negative 1. This one would give me 1 minus a 6, which is negative 5. This would give me a negative 1 minus another 2, would give me negative 3. 1 plus 0 is 1. And then negative 1 plus 4 would be 3. So there's my final matrix. Again, it ended up a 3 by 2, and I knew that was going to happen because I used that idea up there. So just pay attention to what you should be ending up with and make sure that you actually end up with that, and just be careful with each step. Now, they give you more examples than this in your book, so if you want to go back and look at some of those, that would give you just some extra help.